Hello and welcome back to Tingling of 5. Today we're going to be looking at something pretty special. This, what you see in front of you, is a laser power meter. Now this particular one is a Laser Bee from J. Bauer Electronics, and it's able to measure anywhere between 2 milliwatts and about 2.1 watts. So we've got a nice laser power meter here, and I'm just going to take you through what it is. Now it comes with a nice RS232 to USB adapter, that's the blue thing on the side. And this thing you see right now is the thermopile. This is how it's measured. Now you've got to plug that into two of those down there, and you can even data log with your PC through the RS232 to USB ports. So we'll test a couple of these old lasers which have been in my previous videos. I believe all three of these are from budgetgadgets.com. But first I'll take you through the thermopile. So most of it is a heatsink, but this nice little pad in the middle there, that is what you're going to be shining the lasers at. That'll turn the heat energy into a different resistance, which will be measured by the actual Laser Bee appliance. And you shine your lasers at it like so. Now it's easy enough to cable into the actual Laser Bee. There is a supplied guide on how to do that. Obviously you don't want to be touching this while it's in operation, as the heat from your fingers will change the output measured. So don't touch it, just keep it in one place when using it. Now this is it all set up. The brown cable can go into either the middle screw or the one on the left, and the yellow cable has to go into the far right. Again, there's a guide that comes with it which tells you how to do it. To power the device, as you probably saw earlier, is just a simple 9-volt battery. It's happening off screen right now, and it's about to turn on any second, like now. So it boots up, tells you it's by J. Bauer Electronics, which one it is, and we're going to measure some of these lasers. So this one right here is supposed to be 100 milliwatt. This is the first time I'm using it, so it didn't go exactly to plan, but it's a good idea of what happens when you're using it. So currently it's booted up, 0 milliwatt max and 0 milliwatt current. So we're going to shine the laser at it. Obviously we want to keep the laser as still as possible. I've kept this at normal speed, just to show you exactly how it works. And it's counting up. I also have the data logging utility enabled on my desktop. I'll show you that any second. And we're just counting up, counting up. I haven't quite got it in the optimal place, and the laser is at the moment moving. You can see on the back wall of my little tent thing that I'm actually slightly high. The laser is actually going through. But I do have a second attempt, and I do get the maximum value a little higher. Any second, of course. This little tent wasn't exactly ideal for it. I've just moved house, so everything's still a mess, which is why it's not completely level. So with this 100 milliwatt laser, with not the freshest batteries they've had, I think they're probably the original batteries still, I've managed to reach 84 milliwatt max. And I'll show you the output of what I get from the actual data logging. So what you get is this nice little graph thing. That was exactly what I just showed you, but on graph form. And behind it, you actually get this Excel spreadsheet printout, which is .csv. And I also measured the 200 milliwatt red laser, which came out a lot better. So I'd give this product a thumbs up. I'm very satisfied with it. It was quite expensive, but laser power meters are usually a lot more expensive. But now I've got a laser power meter, how about you tune back in tomorrow and I tell you exactly how powerful these DVD burner lasers are. Thanks for watching, everyone.